Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Dear students of Senior 2, this is chemistry class. We are looking at unit number 2 of unit 8, unit number 10. Unit number 10 is talking about the properties of organic compounds and uses of the alkanes. And in this lesson, we'll be looking at the nomenclature and isomerism in alkanes. Those are the main terms that we'll have to look at in this lesson. But before we start off the lesson, I just want to invite you to get ready with your pens and books. Note down some important information that you may use for revision or that may help you to understand the lesson as we move along the lesson together. So let's start by looking at the homologous series. This is the last part that we looked at in the previous lesson, but I just wanted us to start with this again so that we can move freely and we connect with the lesson number 1. What do we mean by the homologous series? As I've said, we talked about this in the previous lesson. This was the last part. So these organic compounds are so many, actually 3/4 of all known organic compounds, these contribute organic compounds. The compounds of carbon and hydrogen, including chlorine, including oxygen, including sulfur, and many others. So for proper studying, because you remember we said in these organic compounds we'll be looking at the structure. We look at the structure, we look at the properties, and then look at the applications. The applications or the uses of these organic compounds. So to look at the structure and properties and applications of these compounds, and basing on the fact that these compounds are very many, the scientists had to group them together. And they are grouped in families. These families are the ones we call, the families of these compounds are called homologous series. Homologous series. So these are the compounds. These compounds have got some similarity. And they have similar chemical properties. They have similar, there is some similarity in the physical properties. They have, the general formula representation is the same. So you'll find that these homologous series or families of compounds have got some similarity. And we need to note that the members of the homologous series are represented by the same general formula. So if we are talking about, we'll talk about the alkanes. Alkanes belong to the group of hydrocarbons. These hydrocarbons, we have different hydrocarbons. I hope probably you had ever talked about or met this word before. The hydrocarbons are compounds of carbon and hydrogen. These are compounds of carbon and hydrogen only. So this, if we talk about the hydrocarbons, we have, under the hydrocarbons, we have alkanes, of which we are going to look at in this lesson. We'll talk about the nomenclature of the alkanes, and then we'll talk about the isomerism. So we'll be under the alkanes. We have alkenes, which we'll have to meet at a later time in the future. And then we have the alkanes. And all those will also be met at a later time in other classes, probably in senior 3. So they are represented by the same general formula. Compounds in the same homologous series are represented by the same general formula. They have similar chemical properties. So these are the characteristics of homologous series. Homologous series. They are represented, as we said, general formula. Two similar chemical properties. Similar chemical properties. And 3, you'll need to note that their physical properties change gradually. So as either the number of carbon atoms increases, we will see that there is a change in physical properties. And this is determined by the molecular mass. This is determined, so that means that the molecular mass will be determining the physical properties. And for the alkanes, any two adjacent homologous series differ by this group, CH2 group. That is called, so they differ. So the compounds in the same homologous series differ by methylene group, which is CH2. That is the difference. So you'll have a difference of CH2 group differing from the first member to the second member. There will always be a difference of CH2 group. So looking at the homologous series, let's talk about the general formula for the alkanes. So alkanes are carbon atoms, as we said before, the carbon atom is directly bonded to 4 other atoms. Since in these compounds, all the carbon atoms utilize their full combining capacity by forming single covalent bonds. What are we talking about here? That when you look at the carbon is using, how many electrons are in the outermost shell of carbon? You need first to know which position does carbon occupy on the periodic table. That is, you need to know the atomic number. Carbon has occupies position number 6 on the periodic table, and therefore it has 6 electrons. So carbon is element number 6. So its electronic configuration is 2,4. What does this mean? It has 4 electrons in the outermost shell, meaning that when you look at the carbon, these are the 4 electrons. If we represent this one as the electrons in the outermost shell, carbon is able to use all these electrons in the outermost shell. And therefore, for that matter, carbon is said to be tetravalent, a tetravalent atom, because it has the ability to use all the 4 electrons in the outermost shell. And for that matter, this carbon in alkanes is said to be circulated. So alkanes are saturated compounds. Why? Because the carbon in alkanes is able to use all other 4 electrons in the outermost shell, unlike other compounds that we look at or other hydrocarbons that we look at. So these alkanes are represented by the general formula. So the general formula for alkanes is given by CN H2N plus 2. That is the general formula for the alkanes. So this one, you need to memorize this general formula. So this general formula will help us to derive the names of these compounds. So this is CN, where N, this N is equal to 1, 2, 3, 4, up to infinity. So meaning N can be even 100, N can be even 1,000, up to infinity. That means N starts from 1. That is very important. This is the general formula for the alkanes. Please note this as we move on. So looking at the nomenclature, how are we going to name these compounds? So there are 2 words that we need to use. 2 words. There is what we call a prefix, and then there is what we call a suffix. These 2 words. So in the naming, when we are naming these compounds, we are not using our own. These are not concocted names. The names are derived from IUPAC. This is International Union of Pure and Applied Chemistry. So we use the rules that are derived by this union. This is a group of chemists who sat together to put down the rules that we use to name these compounds. Because the science that we talk about here is not different from other science in other countries. So that's why there must be a rule that will govern us, that whatever we call, whether we name the compound, given the name, this name is accepted internationally or globally, not only in Rwanda. So we use the prefix. We are just going to look at these 2 terms. So these 2 terms, when we talk about let's start with the prefix. We have the chain lengths. This is carbon atoms. Just look at the screen. Carbon number 1, that is when N is equal to 1. When N is equal to 1, that means carbon is 1, carbon is 2, carbon is 3. So when we use, when carbon is equal to 1, the prefix that we use is meth. That is where we get the name methane. So methane is an alkane that contains 1 carbon atom. Then we get ethane. Then this is eth. Then prop, but, pent. These are some of the Greek words. These words are derived from Greek. And hex, which represents 6. We have been talking about hexagon. These words are derived from Greek. When it is 7, that is hepta. When it is 8, octa. 9, non. 10, dec. So those are the prefixes. So the suffix, so we have known meth, that is the suffix. We have meth, we have eth, so those are the ones we have. Then we have prop, sorry, like this, and so on up to carbon number 10. Now, when we are naming these compounds, we said they are called alkanes. This is the suffix. So these compounds end with the suffix, all of them, they end with the suffix N. So the suffix here, this is prefix, and then we have the suffix. So the suffix here will be N. So meaning we are going to combine these two, meth. So we combine the prefix and the suffix. So for this one, when we combine with carbon number 1, it will be meth, that is the prefix, then we add N. So the first member will be methane. When we go to the second member is eth, that is the prefix, and then we add N, the suffix. So we'll have ethane. When we go to the third member, we have prop. Then we add this suffix, N. So there are two words that are joined together. We join the prefix and the suffix together. So the prefix are these special words derived from the Greek, and then the suffix is the ending. So all of them end with N, so joined together. Carbon number 4, it is but, and then we add N, so that will be butane. Number 5, you would have pent, and then you add this pentane. Number 6, this is hexane. Number 7, you'll have heptane. Number 8, you'll have octane, which is derived from the other 8-sided figure, which is octagon. So those are the words. The words are derived from those letters, or from those Greek words. Now, let's look at we'll have to look at the structure. After looking at the names, we need to look at the structure. How are these compounds being represented? How do we present them structurally? So coming back to this, methane, we have already known that this methane is obtained when carbon is 1. So that means it takes us back to this general formula. Where do we have it? We have this. When carbon is 1, so that means we have 1 here. What about the number of hydrogen? We'll have 2 times 1, then plus 2. This will be 2 times 1 plus 2. So that gives us 4. So that means this is C1H4. So even if we don't put 1, of course it will remain. So this is the formula for methane. When we go to carbon number 2, this ethane, we derive the structure or the formula from the general formula. So that is 2, you remember we'll have 2 here. That is N when N is equal to 2. So that is 2 times 2 plus 2. 2 times 2 is 4, plus 2, that is 6. So we'll have C2H6. Propane, 3 here. Then 2 times 3, 6, plus 2, that is 8. So we'll have C3H8. Butane, that is when carbon is number 4. This is Cn, that is 4 here. Then what about the hydrogen? We'll have 2 times 4, that is 8, plus 2, that is 10. So we'll have C4H10. Pentane, that is C5H. This one will be H. When you look at this, what is the difference here? You'll see from here that is 2 added here, 2 added here, 2 added here. So that means this one will be 12. When you have hexane, you have C6H14. So we said as you move down, there is a gradual difference of CH2. This is CH2. This here you have CH2. You have CH2. I mean the difference. The difference from this one and this, you find it is CH2. The difference from this and this is CH2. This CH2 is equivalent to 14. So there is a difference of 14 as the molecular mass. That is the methylene group. That's how they differ. So we can write this in another form here, where we have C2. This one cannot change. So, but where we have this C2, we may have CH. So if we write these as 2 carbon atoms, and we said the carbon atoms must be surrounded by 4. So this one will be the structure, 4 carbon atoms. So you'll have hydrogen here, hydrogen, 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 which can also be represented as CH3, CH3, like this. If you have this, for example, this one, you'll have, say, how many are they? Make sure the number of bonds that joining carbon are 4. Hydrogen here, hydrogen, 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 hydrogen. So you have CH3, CH2, CH3. This one and this one are the same. So those are the structures of these compounds. Just look at the screen. When we go to the screen, we have atoms ending to number 10, up to the carbons, these molecules up to carbon number 10, which is decane. So decane is C2H22. And you understand how we get that one from the general formula. Then let's go to the isomerism. So isomerism is the existence of molecules, different compounds, represented by the same molecular formula, but they may have different structural formula. Let's look at one of the examples. If we talk about structural isomerism, for example here, let's take an example of this. The first 3 members do not show isomerism. Now, we said this one can be represented in this form. CH3, CH2, CH2, there are 4 carbon atoms. These are 3, then CH3. When you look at this molecule here, you'll find this is also butane, or sometimes called N-butane. So what do we need to see? The carbon atoms are on the structure, but we can rearrange these carbon atoms. If we write it in this form, for example, CH3, C, CH3, this is H, CH3. Look at this one. When you look at this compound and look at this one, these are the same. They have 4 carbon atoms. 1, 2, 3, 4. This is 1, 2, 3, 4. They are the same. Look at the number of hydrogen atoms. How many are they? 3 plus 2, that is 5, that is 7. When you add 3, that is 10. Come back to this one. This is 3 plus 3, that is 9, that is 6, sorry. That is 9 plus 1, that is 10. But when you look at them, the way they are represented, they are different. All of them are obtained from C4H10. These compounds are said to be isomers. These are the isomers. Isomers are compounds of the same molecular formula, but different structures. which molecules in the same molecule have bonded. When you look at the bonding, it is quite different. You see the carbon atoms are on the straight chain. But when you come to this, the carbon atoms are not on the straight chain. They are branches. The arrangement of atoms here is not the same as that. So the arrangement of atoms and the bonds are not the same. This is on the line. These are branches. This can be a branch. So that means these are said to be isomers. Molecules or compounds of the same molecular formula. The molecular formula is this, C4H8, but represented with different structures. These compounds have different names. This one is 2-methyl. This is 2-methyl, 2-methylpropane. 2-methylpropane. So that means N-butane or butane and propane are all isomers of this compound. We can have as many isomers as possible. You can have as many isomers as possible. Let's look at some other examples. This is what we were just mentioning. You need to know that isomers are molecules with different structures, but with the same molecular formula. With the same molecular formula. These are some other examples. You can have, this is pentane. You can write other structures by creating some branches. When you create some branches, then it means you are creating other isomers. Keeping in mind that those branches that you have created, you are not changing the number of carbon atoms, you are not changing the number of hydrogen atoms. So the number of hydrogen atoms remain the same, but they will differ in how the atoms are arranged in space, in how the bonds are arranged in space. Dear students, I hope this is what we are supposed to look at. We are supposed to look at the nomenclature, and we have looked at the nomenclature of these compounds up to decane, up to carbon number 10, and then after that we are supposed to look at the isomerism, where we said molecules with the same molecular formula but different structures. Thank you so much. I hope to see you in the next lesson. Bye-bye.